Hello, and thank you for inviting me to give this presentation. It's a pleasure to be with you all today. One quick disclaimer before I begin is that obviously I'm not pretending to be a scientific expert, but rather I take the approach of someone who's always had a keen interest in this topic for quite a while, and I've read and viewed much material on it, which I wish to share with you today with this presentation. So with that, let's begin. There's an old adage I'm sure many of you know. We've heard it expressed in stories and songs, and possibly in our own personal lives. And that's, you don't know what you got till it's gone. And in thinking about the climate crisis we find ourselves in at present, due to the burning of fossil fuels by human beings, this particular message sticks with me more than anything else. Especially when we take a look at other planets in our solar system and the stories they tell, because there were other worlds that began with just as much promise as the Earth, but something went wrong. Our solar system is approximately 4.6 billion years old. Our sun formed from a collapsing cloud of gas and dust, where impacts among the atoms heated the surrounding haze, and hydrogen began to fuse into helium, and the sun turned on. A little further out from the sun, there was a lot of orbiting dust and rocks which collided and compounded due to gravity to form rocky worlds. There were also many violent collisions and impacts in those early days of the solar system, sort of a sweeping up of the debris that was orbiting our newborn sun. But eventually, things settled down into the planets that we know today. And here's a present illustration of our solar system. Astronomers will sometimes refer to the Goldilocks zone in a given solar system. This is the habitable zone where the temperature from the nearby sun is not too hot and not too cold for liquid water to exist on a planet, thus enabling the potential for life. In our system, this zone originally encompassed the orbits of Venus, Earth, and Mars. Venus and Mars on the opposite outer edges, and Earth smack in the middle. So let's first take a look at Mars tonight. Today, Mars as we know it is a cold, barren desert world with rustic rock and parched sand. But the evidence shows it wasn't always this way. 4 billion years ago, Mars was quite a different world. Its atmosphere was dense enough and warm enough to support seas and rivers of running water. In fact, Mars, the red planet, was once blue like ours. Today, we can even see the dried up remains of those ancient riverbeds, where potentially life-supporting water flowed across the planet. Indeed, Mars had all the right conditions for life to emerge. Rich with minerals and the organic building blocks that make up life, it is very well plausible that life did take hold there. For hundreds of millions of years, its seas and rivers flowed freely across the Martian surface. Mars was a hospitable world. But then about 3.7 billion years ago, something happens and Mars begins to die. The planet gradually got colder and its atmosphere thinner. The liquid water it had was either soaked in the ground and froze, or froze at the surface. A lot of it got transported to the poles to form the thick ice caps we see there today. If there was any life on Mars, it most likely perished as the daily surface temperature dropped to a negative 80 degrees below zero. And so, over time, the planet turned into the dry, barren wasteland that we know of it today. So, why did this happen? What caused Mars to die? Thanks to the work of NASA utilizing the MAVEN spacecraft, scientists appear to have found the answer. MAVEN, which stands for Mars, Atmosphere, and Volatile Evolution, is a spacecraft that was sent in 2013 to orbit Mars and investigate its atmosphere and ionosphere. The findings from that mission provided valuable insight on how Mars's climate had changed over time. What they learned was that Mars had lost its magnetic field that protected the planet from the sun's solar wind. You see, what happens is the sun's outer corona emits streams of highly charged particles called the solar wind. This solar wind travels through the solar system at 100 miles per second, striking anything in its way, including planets and moons. A planet like the Earth, though, has a magnetic field which effectively forms a protective bubble around the Earth, diverting the solar wind and other ionizing radiation away from our planet. This protective magnetic field is generated deep inside the Earth at its core. It occurs because of the convective motion of hot liquid mantle moving against the Earth's solid iron-nickel core. At night, we can sometimes see the protective field at work, especially near the northern latitudes with the stunning display of auroras. And so, just like Earth, Mars once had a molten metallic core generating a magnetic field around the planet. Scientists know this because they found evidence of it in the rocks there. But sadly, Mars's protective shield did not last. Around 3.7 billion years ago, Mars's magnetic field shut down. Once it did, the solar wind from the sun started to strip away Mars's atmosphere. Soon its water disappeared and the surface temperatures dropped, leaving Mars as a cold, dead planet. So then, why did Mars's magnetic field stop working? What happened deep in its core that prevented it from continuing? It turns out that Mars's fate was actually sealed at the time of its own creation, 4.6 billion years ago. During the early history of the solar system, as planets were forming from the dust and rocks orbiting the sun, Mars just happened to form a little further out in a different area where there was less rocky material to build a planet, thus making Mars smaller. It's this critical size difference that sealed its fate forever. Because of its smaller size, there was less thermal energy coming from the planet's interior. So, while initially Mars seemed to thrive, deep at its center, the planet was dying. One by one, its volcanoes went quiet, its core cooled, it lost its protective magnetic shield, and the solar winds stripped away much of its atmosphere. So that eventually, what was once a possibly life-sustaining, vibrant planet became a cold and desolate world that today treks a lonely path through the darkness of space. So what about our other planetary neighbor, Venus? Unlike smaller Mars, it has more mass. It's nearly identical in size to the Earth. In fact, sometimes it has been called Earth's sister planet or twin. But other than size, Venus is a very different place. Its atmospheric pressure is 90 times that of Earth. The surface temperature is 900 degrees Fahrenheit, hotter than the hottest household oven. This is not because the planet is a little closer to the sun, but as we'll find out, because of something else. 4.4 billion years ago, Venus was actually quite similar to the Earth. Evidence shows it had oceans and rivers, its climate was temperate, and the planet was rich with the potential for life. But then something happened that caused Venus to change. the planet started to heat up and lose its water. In 2005, the European Space Agency sent the spacecraft Venus Express to the planet, equipped with instruments to measure the Venusian atmosphere. By examining the isotopic composition of hydrogen in its atmosphere, scientists were able to determine that Venus lost most of its water long ago. So, why did this occur? It happened because of a change in the sun. A star like our sun becomes gradually brighter as it ages. All main sequence stars do. It's part of the stellar evolution process of a sun. And so, as our young sun warmed up in the early days of the solar system, the radiation balance started to shift, and the sun became brighter and hotter. As a consequence, the surface of Venus heated up, causing more and more evaporation of its water, transforming it into water vapor in the atmosphere. Water vapor is a greenhouse gas, so as more water was evaporated, the hotter the planet got, which in turn caused more evaporation. This is what's called a positive feedback loop, when the reaction of something leads to an increase in that very reaction. Meanwhile, around the same time that was happening, Venus went through a period of extensive volcanic eruptions. In fact, as discovered by NASA's Magellan spacecraft launched in 1989, it was found that there are more extinct volcanoes on Venus than at any other place in the solar system. So, back in the time when those volcanoes went through a very active period, they spewed huge amounts of carbon dioxide into the Venusian atmosphere. Eventually, this, in combination with its loss of water, pushed Venus to a tipping point, and a runaway greenhouse effect took hold. Its oceans and its rivers eventually disappeared, followed by any hope for life that might have been there. And when I think about that, I wonder sometimes if even basic life was able to take hold there, when that life might have first sensed that something was wrong. In a very deep way, Venus with its runaway greenhouse effect is an important object lesson for us. For today, Venus is covered completely in clouds, stained yellow by sulfur. Its atmosphere is choked with carbon dioxide. On its surface, searing heat bakes its barren and reddish landscape. It's really a planetary inferno, and there's not likely to be anything alive there because organic and biological molecules would simply fall to pieces. Venus really is the one place in the solar system that's much like hell. In stark contrast to Venus is its neighboring world, a comparative heaven, our little planetary home, the Earth. Here, the atmosphere is 90 times thinner. Here, the carbon dioxide and water vapor make just a modest greenhouse effect. Here is a vibrant, pleasant world, positively rippling with life. It's a planet with blue nitrogen skies, oceans of liquid water, cool forests, soft meadows, and as planetary scientist Carl Sagan once said, the Earth is a place to our eyes more beautiful than any other we know. But it too has had its share of turbulent periods, from times of massive volcanic eruptions to cold and wintry ice ages, yet through it all, life has managed to maintain. And then about 11,000 years ago, the Earth's back and forth swings of ice ages came to a stop. A new and gentle climate period began. It's the one we live in now. And the good news is, it's due to last for another 50,000 years. Except there's just one problem. We can't seem to stop burning fossil fuels. If we could, we'd be home free. So let's take a closer look at the greenhouse effect. Incoming light from the sun hits the surface of the Earth. This heats up the planet. The heat then radiates back into space, but carbon dioxide in the atmosphere absorbs much of that outgoing heat, sending it back to the surface. And that's all there is to the greenhouse effect, really. It's just bookkeeping of the energy flow. If we didn't have any carbon dioxide in the atmosphere, the Earth would become a frozen planet. So, a little greenhouse effect is a good thing, but too much of it will destabilize the planet and destroy our ecosystem. Think Venus. Currently, we are dumping huge amounts of carbon dioxide into the atmosphere by the burning of coal, oil, and gas that has long been buried in the ground. And so the carbon dioxide in the atmosphere continues to increase along with the Earth's global average temperature. This is the Keeling curve. It's a graph that tracks the accumulation of carbon dioxide in the Earth's atmosphere based on measurements taken at Mount Loa Observatory in Hawaii. It's named after oceanographer Charles David Keeling, who devised an accurate way to measure carbon dioxide in the atmosphere in the 1950s. It measures in parts per million. Before the Industrial Revolution, the amount of carbon dioxide in the atmosphere was about 270 parts per million. By 1958, it was at 316 parts per million. And as of April this year, it reached a new all-time high of 419 parts per million. The Earth has not seen this level of carbon dioxide for at least 3 million years. And how do we know this? Because it's written in the water. The Earth keeps a detailed diary written in the depths of glaciers near the poles. These ice layers have ancient air trapped inside them, and from examining ice core samples drilled out from deep within the glaciers, scientists can read the unbroken record of the Earth's atmosphere spanning back through the millennia. So, at present, we are at carbon dioxide levels that are unparalleled to anything the Earth has seen since the existence of human beings. And so, how do we know this alarming increase in carbon dioxide is due to human actions and not natural processes such as volcanic eruptions? We know because volcanic carbon dioxide has a distinct signature. It's slightly heavier than the kind produced by the burning of fossil fuels, and scientists can tell the difference when they examine samples at the atomic level. In fact, volcanic carbon dioxide is not even 2% of the 30 billion tons of carbon dioxide that humans are cranking out each and every year by the burning of fossil fuels. And with this shocking rise in carbon dioxide levels, the Earth's global average temperature is increasing. In fact, 19 of the warmest years on record have occurred since the year 2000, and last year, 2020, was tied with the warmest year on record. So, if we just keep doing what we're doing, business as usual with the burning of fossil fuels, we are in for a terrible time. Killer heat waves, record droughts, rising sea levels, the mass extinction of many species, including perhaps jeopardizing our own existence. We already are seeing the impacts of this climate crisis now across the planet, including the recent devastating fires in Australia and California. This, in conjunction with the massive loss of rainforests around the planet, is extremely alarming because forests are actually one of our ways out of this climate crisis. Forests are big climate regulators at a global scale, but the problem is that trees are now being cut down at such a rate that nearly a third of our carbon dioxide emissions are caused by deforestation. Earth's ice, frozen for thousands of years, is melting. Recently, scientists have conducted a global assessment of ice loss from the poles. Antarctica is losing 3 times as much ice as it was 25 years ago, and Greenland is losing 5 times as much ice now as it was 25 years ago. In fact, in the prior summer, Greenland had its biggest single-day ice melt on record, with 12.5 billion tons of surface ice lost to the sea in a single day. And this causes another problem, a positive feedback loop. Remember this from Venus? It works like this. The more ice that is lost, the more white surface near the poles then is lost. White surfaces reflect heat away from the Earth. And so, with ice melt, there is less white surface, thus the heat remains, causing yet more ice melt. And it gets worse than that. The permafrost is beginning to thaw around the land in the Arctic regions. Permafrost is the ice-covered soil that has remained frozen over much time, in many cases over hundreds of thousands of years. When it thaws, it releases methane gas that had been locked away in the bits of organic matter from old leaves and plant roots that grew thousands of years ago. That released methane gas then rises into the atmosphere. And the problem with that is methane is also a greenhouse gas that is actually 80 times more heat trapping than carbon dioxide. We sometimes hear scientists talk about a tipping point in our concerns on the climate crisis. If the permafrost continues to melt, many believe that just might be our point of no return. And so it can all sound rather depressing and quite daunting, not exactly a pick-me-up message. But I don't want to convey a message of hopelessness, because it's not. We have to remember that human beings were able to tackle big issues before, and that we do have the ability as a species to make fundamental changes. We're surrounded by examples of them. For instance, there used to be the divine right of kings, but for the most part, that's now gone. Slavery, which existed for thousands of years, has almost entirely been eliminated. Women, systematically mistreated for millennia, are gaining political and economical power. Many infectious diseases that have killed and crippled since time immemorial have been nearly eradicated thanks to our efforts in medical science and vaccinations. And a more apropos example to environmental issues was that in the 1970s and 80s, we learned that the Earth's protective ozone layer was being depleted due to chlorofluorocarbons being released into the atmosphere from refrigerants and aerosols. And so the world came together with the Montreal Protocol Agreement, and we changed our ways. And now the ozone layer is on the mend. So we do have the capacity to act and change and deal with serious existential concerns, but we have to act. In simplest terms, we have to shift our energy sources from fossil fuels that produce greenhouse gases to renewable energies that don't. And there's an inexhaustible source of clean energy for the world to use. The winds themselves are solar powered because our sun drives the winds and the waves. And unlike solar collectors, wind farms take up very little land, and none at all if offshore where the winds are strongest. If we could tap even 1% of their power, we'd have enough energy to run our civilization. And also, more solar energy falls on the Earth in 1 hour than all the energy our civilization consumes in an entire year. If we could harness just a tiny fraction of the available solar and wind power, we could supply all our energy needs forever and without adding any carbon dioxide to the atmosphere. We all know that efforts are already currently being made around the planet towards this end, but it's not enough. We really need to ramp it up because we've reached a point where there can be no more debate or special interests on this global emergency. Climate change threatens every single person on the planet. And so I began tonight's talk with examples of other worlds that had just as much promise as the Earth for habitability and life. But something went wrong. If any life did exist on those other worlds, it was most likely quickly snuffed out. And while on those other planets the changes were due to natural processes, here on Earth it will be due to our own hand. If we destroy the habitability of the Earth and our civilization, all we'll be left with in the end is the knowledge that we could have prevented it and did not. And so I wanted to end my talk tonight with this final image of the Earth. It was taken from the surface of Mars by NASA's Curiosity rover. You can barely make out that speck of light that is the Earth just off the horizon in the Martian night sky. In a way, I thought, it serves as a reminder that Mars, which like the Earth, once had oceans and rivers and the potential for life, yet now is a lonely and desolate place where the only real sign of life is the illuminated Earth that crosses its night sky. You don't know what you got till it's gone. That concludes my presentation. Thank you very much.